Hello, good morning. My name is Mike Zink. I'm from the University of Massachusetts, Amherst. For most of you, that is actually part of Massachusetts, west of the I-95 corridor. I work like 20 miles, 50 miles north of the MGH-PCC, so for a person to you guys, it's easy for me to get there. If you ever have a chance, come out and visit us. It's a nice, visit the MGH-PCC. It's a nice, very nice facility with a lot of things to learn. I'm here to talk a little bit about the returns of interference or whatever going on. Let me talk a little bit about the Open Cloud Testbed. Peter did a fantastic job of introducing it, so I can actually kind of skip this slide. The only thing I want to say is I'm not doing this all alone. I have support from Peter and Oran. We have Lisa from Northeastern, and Martin Herbert from BU, and my colleague David Irwin at UMass. So Peter told you quite a bit about the OCT already and what our plans are, and I just want to skip that to give a little bit more time to talk a little bit about the inner workings of this. So here what you see is actually what we built, and I'm not going to want to overwhelm you with you. I only have 10 minutes. There's no way I can get through all of this. There will be a poster. I have a note on this afternoon. Hakan is somewhere here. He will actually, Hakan's back there. He will talk about this and give you much more detail. What I want to tell you is actually two messages I want you to take away from this slide. First of all, this is what we proposed to NSF, what we're going to build. All the rest you see came into place over time. Great support from industry. Two Sigma made a huge part with the donation, where we used part of it. Wonderful support from with ESI and then also AMD silings or FPGAs. But what I also want to come across here is we're not only providing bare metal service for research and making this elastically available, but we're tying in a lot of initiatives within the MGH-PCC, but also nationwide. And I think that's a nice and a wonderful thing for systems researchers, because we're not doing this in isolation, we're doing this really as a nationwide effort, kind of going internationally, hopefully soon, once we kick out some of the legal issues on that side. So this is our infrastructure. Again, I don't have too much time. If you want to look at this in more detail, come back later on. A little bit of an idea is I'm probably the first one to show really a graph here. What you see here is time on the x-axis, and then you have two y-axes where you see on the red line the resources, that specific resource we're making available in OCT, and then the blue line is showing the percentage of the usage. Yes, I give an example that's a little bit different from what Peter, I think you mentioned, and that is here you see that at some time between the summertime over 2021, academics sometimes also take a break, so the load is really low. So you can actually, at this time, we could have used ESI to give resources, maybe to an HPC cluster, maybe to NERC, to give make those resources available to others. So it shows you that when you look at the data over time, the usage is never constant. And then you can bring in bare metal servers or give them away for a certain time. We have other examples where you see ahead of deadlines. This is going, the usage is going. And we're working here with Red Hat and other teams to integrate ESI to make this really happening, so we can allocate these resources, make them dynamically available. We're exposing some of our hardware right now to the NSF Cloud Testbed. And so what we've done is actually that modifications the team did went actually into the code base for Cloud Lab and went into the code base for ESI, so others who would like to reproduce that can do this. Let me talk about the other exciting part we have, is we're bringing accelerators into the testbed. Commercial labs have FPGAs now, but they don't have them available as we would like to have them available for systems researchers, right? There's a lot of abstraction, a lot of APIs that keep away from the core details. What we have done is we have integrated 16 FPGAs in bare metal service that are available for the systems research community. They are networked, so they both have getting into details, 200 gig interfaces. You can really do some exciting stuff on that side in terms of networking research, disaggregation research, lots of different avenues. And the team at Northeastern has done a fantastic job in also building a workflow of this. So you can now bring up a VM with all the tools you need to create your bit stream and then deploy that on the FPGAs very nicely set. That makes life easier, and I think that helped with attracting a bunch of people to it. We we now support 15 research groups nationwide with that. This is where, we come, on one side we're becoming to international, we have some requests from outside the country to work out how we're going to do that. We got additional funding from NSF to work on smart NICs and enable P4. Some of the networking folks might be familiar with that. And working with Fabric team, with people from the University of Nebraska and USNet, to make this not only available on your testbed, but indeed throughout the infrastructure throughout the country. And we see right now that there's a lot of demand for these FPGAs. People not getting resources when they want them, and so the only option we have right now is actually do a build out in our first years of the project to get more resources available. Mr. Ranga is going to give a deep dive tomorrow at 1:15, and that's where you can learn a lot more about the work that's happening with respect to FPGAs. I want to give a shout out to the Fabric program because I want to show you that we're not only locally connected within the GHBCC or within the region, we're also working with a nationwide project. Actually, Fabric is an international project because we also have nodes in Holland and in Europe and in Asia. And so that is actually, I don't know, there's some people around who are still familiar with Genie. So Fabric is a little bit of a follow-on of Genie, building this international cutting-edge research infrastructure that allows you experimentation on a large scale with programming, program networking, program storage, and actually compute available. And what we've been working on, and Paul can tell you more about this, we're actually building connection, which they call a facility port into OCT. So now you can actually run experiments that span, the world if you want to, using bare metal servers on our side, but also using other resources across the globe. And again, we're working with the Fabric folks, and then they will put the same FPGAs we have in their testbed, so you can actually do advanced networking experiments based on And Paul, who's actually coming all the way up from North Carolina, will actually give a deep dive to 315 on Fabric and give you much more details. A couple of things we have in progress right now: exposing our hardware right now through CloudLab, which is another NSF testbed. Many researchers in the country are using with, but there's also another one that's called Chameleon Cloud, and we thought it would be nice if we make some of our hardware also available through Chameleon Cloud because it reaches then another set of researchers who are familiar with that interface, with that API, with that infrastructure. We have the cluster up right now, but it's not ready to make it public for use, but that will happen fairly short. We're working on some of the ESI cloud integration on the networking side, and the bare metal server side. We're working to do a little bit more on the networking side. And we're in the progress of further onboarding FPGA users. If you're interested in this, to me, talk to Saranga, come to the dive later on. Outreach is one of our main missions here, so we're also gearing up for different summer programs our institutions have, working with high school students, getting them introduced to cloud computing, to distributed systems research. If you have any needs on that side, let me know, talk to me, I'd be happy to help. And then coming up in the fall, we have the IEEE International Conference on Cloud Engineering happening here in September. The deadline is approaching fast, but if you have some research work in cloud or in cloud systems, please submit your paper there. There's a couple of pamphlets out there on the registration desk. If your cameras can read the QR code, you will get to the website. Last words about the future. So when we wrote the proposal, NSF, part of the solicitation was we have a 3-year site visit that just happened in the fall, thanks to the wonderful work of the whole team. We passed that, so you got to stick around with us for the last 2 more years. It's the good news. And so we'll continue to evolve with OCT. So we want to use the FPGA build out I mentioned a moment ago. And then there comes the bad news. The hardest part is how do we make this sustain after funding ends, and talk to our advisory board about this afternoon. I'm also looking forward to getting any feedback and any insights from you guys who maybe run infrastructure in the past, research how we do this. My time is almost over, so I would like to leave you with one question, and then hopefully when you catch me in the hallway or whatever, I'd like to get some answers from you, especially from the research and from the open source community. What are the needs you have from VML Testbeds? What do you need? Is there new software, new hardware you would like to see, so we can help you advance your research? With that, I want to thank our industry partners, Red Hat, AMD Xilinx, and Two Sigma have been wonderful supporters. Also, what's really important for me, I want to thank the students, the undergrads and the grad students that have been working on this project, and our research engineers and scientists, because without their hard work, it could not be. Thank you very much.